What does the solar system have to hide? We know a lot about the solar system. It is not located at the center of the Milky Way, but in one of the 4 spiral arms of our galaxy, the Orion Arm. Orbiting the center of the Milky Way, it travels at a phenomenal speed of 828,000 kilometers per hour, or 515,000 miles per hour. It takes 230 million years to circle the galaxy. We also know that the solar system formed around 4.5 billion years ago. However, there is still a lot we don't know about our solar system. How large is it? What's its boundary? The sun's gravitational influence or the Kuiper belt? Why does it seem to be split in two, with telluric planets on one side and gaseous planets on the other? Dear traveler, welcome. Today we're embarking on a journey that will take us through the entire solar system in an attempt to unravel its well-guarded mysteries. During this space odyssey, we'll explore the planets of the solar system from the Sun to the Kuiper belt, via Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, the 9th planet that's no longer a planet. So are you ready to discover the fruits of recent research and observations of the solar system to better understand the universe around us? Immediately take off towards the Sun. But before we set off on a new adventure, remember to like the video and subscribe to the channel so you don't miss a thing. Thank you, and have a great trip! Let's start our exploration with the Sun. The Sun is the heart of our solar system. It's a yellow dwarf star, in other words, relatively small by universe standards. And yet, with a diameter of 1.39 million kilometers, or 870,000 miles, the Sun remains the largest object in our solar system. It's 109 times wider than our planet. Its size and mass are so great that its gravitational force holds all the planets in the solar system in orbit around it. The Sun is a fascinating star. It appears yellow to us from Earth, but is in fact white. It is 4.5 billion years old, but only halfway through its life. Within 5 billion years, it will swell, shrink, and then die out. The Sun's rays take 8 minutes to reach us. This means that if the Sun suddenly went out, we wouldn't know until 8 minutes later. The Sun is the origin of life on Earth. If there were no more Sun, we'd be in permanent darkness. Temperatures would plummet to minus 40 degrees Celsius or minus 40 degrees Fahrenheit within a few weeks, then to minus 100 degrees Celsius or minus 148 degrees Fahrenheit after several months. The oceans would be covered in ice. The Sun is indispensable to life on Earth, but it can also be dangerous. Have you ever heard that you should never look at a solar eclipse without protective glasses? The Sun emits powerful electromagnetic radiation in the form of both UV and X-rays. It also emits particles in the form of violent solar winds and regularly causes powerful solar flares. Our atmosphere protects us from these dangers. Because the Sun is composed mainly of hydrogen and helium, it is difficult to estimate its precise size. Its boundaries are blurred. According to studies published over the last 50 years, the extreme values of the Sun's radius differ by 1,500 kilometers or 930 miles. But studying the Sun is key to understanding our solar system. That's why NASA launched the Parker probe in 2018. Its objectives? To study the outer part of our star's atmosphere, understand the physics of the Sun and thus the formation and evolution of stars, learn more about solar winds and how to protect ourselves from them, on December 4th, 2019, a year and a half after the launch of the Parker probe, NASA announced some important discoveries. The Sun may be far more unstable than previously thought. The probe studied solar winds and recorded strange movements, rotations, deviations, and reversals. Solar winds are in fact extremely turbulent. In April 2021, the Parker probe was just 13 million kilometers from the Sun, the first time a space probe had come so close to our star. By the end of 2024, it should be grazing our star, just 6 million kilometers from its surface. It will finally be able to accurately study the Sun's temperature, its magnetic field, the composition of solar particles, and their movements in the solar environment. Perhaps we'll finally know why the solar corona can be up to 300 times hotter than the Sun's surface, with extreme temperatures of up to 1 million degrees. Just a few years after the launch of the Parker probe in February 2023, NASA made another surprising discovery while observing the Sun. Take a look at these images. A strange filament of plasma can be seen detaching itself from the Sun before spinning around a vortex towards the North Pole. For the moment, scientists can't explain this observation, but they do have an idea. Most likely, it has something to do with the Sun's changing cycle. Every 11 years, the Sun's magnetic field reverses, marking the start of a new cycle. The last cycle change took place at the end of 2020. With each cycle change, matter is disturbed and becomes more chaotic. ESA's Solar Orbiter satellite, launched in February 2020, may soon be able to provide us with some answers. There's still a lot to learn about the Sun, and each new discovery constantly challenges what we've already learned. Recently, in November 2023, a study revealed that the Sun may be smaller than previously thought. Methods for measuring the size of the Sun have evolved and become more refined. In the 1970s, we relied on total solar eclipses. 20 years later, experts relied on the oscillations caused by the Sun's waves to refine measurements. In the 1990s, it was discovered that the Sun was about 0.05% smaller than previously measured. More recent measurements have revealed that the Sun is even smaller, by a fraction of a percent compared with measurements taken in the 90s. A detail? No, because even the smallest fraction of a percent will be important for understanding the Sun's subtle internal structure. Let's move away from the Sun to continue our exploration of the solar system. The closest planet to the Sun is Mercury. It orbits at a distance of 0.4 astronomical units from the Sun, i.e., about a third of the distance that separates us from the Sun. And yet, it's not the hottest planet. The record is held by Venus with its dense atmosphere that creates a powerful greenhouse effect. Mercury's surface temperature ranges from minus 180 degrees Celsius, or minus 292 degrees Fahrenheit at night, to 430 degrees Celsius, or 806 degrees Fahrenheit during the day. Although Mercury is the closest planet to the Sun, it is not the hottest. Mercury's average surface temperature is 167 degrees Celsius, or 332 degrees Fahrenheit, compared with Venus's average of 462 degrees Celsius, or 863 degrees Fahrenheit. Because Mercury has almost no atmosphere, sunlight is 7 times brighter and more intense than on Earth. If you were on Mercury, the Sun would appear 3 times bigger than it does from Earth. Barely larger than the Moon, Mercury is the smallest planet in the solar system. It is almost 20 times less massive than our own planet. It's also the fastest. It orbits the Sun in just 88 days at a speed of 47 kilometers per second or 30 miles per second. Mercury is a telluric planet, i.e. composed of a core, a mantle, and a crust. Its core, composed of iron and nickel, is particularly imposing, with a radius of over 2,000 kilometers, or 1,300 miles, representing 85% of the planet's radius and over 40% of its volume. This makes Mercury the second densest planet in the solar system after the Earth. It is also the only telluric planet, along with our own, to have a magnetic field. Mercury's surface is riddled with craters and escarpments, just like the far side of the Moon. Yes, there's no atmosphere to stop asteroids, but there are also large, smooth expanses which could be the result of lava flows. As you can see, Mercury is an interesting planet, but it's not likely to harbor life. That's why only 2 probes have visited the planet closest to the Sun so far. Between 1974 and 1975, Mariner 10 took 2,700 photos of Mercury and mapped 45% of its surface. In 2008 and 2009, the Messenger spacecraft flew over Mercury 3 times before orbiting the planet. This mission mapped up to 95% of Mercury, photographing previously unknown areas. It collected 277,000 photos of Mercury and established a 3D model of its magnetosphere. A new mission is now underway to find out more about Mercury. The Bepi-Colombo mission from ESA and the Japan Aerospace Exploration Agency kicked off on October 19, 2018. 2 probes will be placed in Mercury orbit by the end of 2025, Mercury Planet Orbiter and Mercury Magnetospheric Orbiter. This is the riskiest mission ever undertaken by ESA because of Mercury's extreme temperatures, but also because of the energy required to reach the planet's orbit, which is very close to the Sun and subject to enormous gravitational forces. On June 27, 2022, Bepi-Colombo already delivered some impressive images of Mercury, taken at a distance of 800 kilometers or 500 miles from the planet. In these photos, you can see that Mercury looks a lot like the Moon. While we await the arrival of probes in Mercury's orbit, scientists have made some important discoveries in recent years. We already knew that Mercury shrank several billion years ago, but a study published in October 2023 has revealed that it's still doing so. Why is this? Mercury's crust is not a very good thermal conductor. It reflects back a large proportion of the sun's rays instead of absorbing them. As a result, despite temperatures that can reach over 400 degrees Celsius or 752 degrees Fahrenheit, Mercury's gigantic core gradually cools, causing the planet to shrink. A bit like an apple that stunts as it ages. The MESSENGER probe had already shown that Mercury had shrunk by at least 14 kilometers or 9 miles in diameter over the last 3 billion years. Since then, even more recent signs of the planet's contraction have been discovered, showing that these processes are still at work. Shortly after these revelations in November 2023, another major discovery once again put Mercury in the spotlight. Salt glaciers were discovered near the planet's North Pole. In other words, this was the first sign of potential life observed on Mercury. According to the scientists' observations, these layers of salt could harbor some form of subterranean life, as in salt ponds on Earth. Some of Mercury's subterranean zones could therefore be habitable. What's more, these glaciers contain volatile compounds such as sodium, potassium, and sulfur, long thought to have been eliminated from Mercury's surface due to its proximity to the Sun. This discovery suggests that these salt layers were formed in the distant past, when Mercury's volcanoes were still emitting sodium-containing water vapors. Let's continue our journey through the solar system. Mercury's neighboring planet is Venus. Venus is the hottest planet in the solar system. It's a veritable hellish planet. Its thick atmosphere, rich in carbon dioxide and clouds of sulfuric acid, retains the sun's heat, creating an intense greenhouse effect. The average temperature on Venus's surface is 462 degrees Celsius, or 863 degrees Fahrenheit. This makes Venus the hottest terrestrial planet in the solar system. As Earth's neighbor, Venus is often considered our planet's twin. The two planets share many similarities. Like our planet, Venus is composed mainly of rocky material, contains some water, and has an atmosphere. Its size and mass are comparable to our own, as is its surface gravity. Scientists even believe that Venus was once habitable. It may even have contained oceans. It was the runaway greenhouse effect that turned it into the hell we know today. Today, temperature, pressure, winds, and sulfuric acid rain make Venus an uninhabitable world. Winds on Venus can reach 700 kilometers per hour, or 435 miles per hour, 300 kilometers per hour, or 200 miles per hour more than the strongest winds ever recorded on Earth. Scientists don't expect to find any form of life on Venus, but they continue to study the infernal twin in the hope of finding traces of past life. Or, to better understand how it evolved in this way. This is why Venus is of particular interest to researchers. At least 3 space missions should be dedicated to this planet over the next decade. In the meantime, scientists are continuing to work on existing images of Venus. In March 2023, researchers carried out a new analysis of images recorded over 30 years ago by NASA's Magellan probe. We now have evidence that Venus is the scene of intense volcanic activity. These radar images from the early 90s show what looked like the eruption of a lava lake. In the images, a crater can be seen changing shape, expanding, and overflowing with molten rock. According to the researchers, this is one of the most convincing pieces of evidence of volcanism on Venus to date. A shocking discovery, as we didn't expect to find this type of evidence before the 2030s. Above all, it's a first step towards learning more about Venus's volcanism, a crucial step towards a better understanding of how its runaway greenhouse effect came about. In November 2023, another discovery stirred the scientific community. This time, researchers detected atomic oxygen in the atmosphere of Venus. This discovery may help us better understand why, despite all their similarities, Earth and its neighbor are so different. Atomic oxygen was discovered at 17 sites in Venus's atmosphere, on both the day and night sides, at an altitude of around 100 kilometers or 60 miles. Be careful not to confuse molecular oxygen, or O2, with atomic oxygen, or O1. Molecular oxygen is present on Earth and we breathe it. It has not been found in the atmosphere of Venus. It's atomic oxygen, made up of single isolated oxygen atoms, rather than linked oxygen atoms, that has been found on Venus. It is also found on our planet at high altitudes. Atomic oxygen is created by a chemical process called photodissociation. This phenomenon occurs when a molecule dissociates under the action of light radiation. In other words, oxygen is converted from a molecular to an atomic form by solar photons. What would explain the presence of this compound in Venus's atmosphere? Venus's atmosphere may be composed mainly of carbon dioxide, or CO2. When sunlight strikes this CO2, a process of photodissociation takes place. The CO2 is split into atomic oxygen and carbon monoxide molecules. When these atoms migrate to the night side of Venus, they bond again to reform CO2. What can this discovery tell us, given that we already know that Venus is not habitable? In fact, this discovery is a major step forward in our understanding of Venus's atmospheric temperature profile, cooling processes, and wind speeds. For some paleontologists, atomic oxygen is a sign that Venus was once wet and warm. Just over 41 million kilometers from Venus lies planet Earth. Earth lies in what is known as the habitable zone of the solar system. The habitable zone corresponds to an area that is neither too far nor too close to the sun, so that liquid water can exist. The Earth is exactly in the habitable zone. It receives around 1,000 watts per square meter of energy radiated by the sun. But as we approach the sun, this amount of energy increases. Beyond Venus, it is too great. Water cannot remain in liquid form and will vaporize. Beyond Mars, Earth's other neighbor, the planets no longer receive enough energy from the sun. Water exists only in the form of ice. The presence of liquid water is the first criterion for a planet's habitability. Like the other planets in the solar system, the Earth revolves around the Sun. One complete revolution lasts 365.25 days. To express the distances between celestial objects, a unit of length was invented. This is the astronomical unit. It corresponds approximately to the distance between the Earth and the Sun, i.e., about 150 million kilometers, or 93 million miles. The Earth rotates on itself in 23 hours and 56 minutes. While Mercury and Venus have no satellites, the Earth does, the Moon. The Moon forms shortly after the Earth. It is the gravitational interaction of our planet with its satellite that creates the tides and stabilizes its axis of rotation. The Earth is the densest planet in the solar system. Compared to Mercury, Venus, and Mars, Earth is the largest and most massive of the 4 terrestrial planets. 71% of its surface is covered by water, or ice around the poles. Over the course of an Earth year, the distance between the Earth and the Sun varies. This is because the Earth's orbit around the Sun is elliptical rather than perfectly circular. On the night of January 3, 2024, the Earth was closest to the Sun, at a distance of around 147 million kilometers, or 91 million miles. We say it was at its perihelion. Perihelion, or closest distance to the Sun, is the opposite of aphelion, the maximum distance between the two. The Earth will reach its aphelion on July 5, 2024. The distance separating us from the Sun will then be 152 million kilometers, or 94 million miles. So there's a difference of 5 million kilometers or 3 million miles between perihelion and aphelion. However, this is not a determining factor in the Earth's seasons. What determines whether we're in summer or winter is the tilt of the Earth on its axis of rotation. A recent study has shown that the Earth is not as special as we think. Life could well have arisen on another planet. In fact, the slightest minor change in the history of our solar system could have given rise to life elsewhere than on this planet. Vertiginous when you think about it. Above all, scientists maintain that the habitability of a planet is not a permanent factor. Venus and Mars may have been habitable in the past. Today, however, they are far from our idea of a hospitable world. The very concept of the habitable zone is more complex than we once thought. The Sun's habitable zone is not the same as that of Proxima Centauri, for example, the nearest star in the solar system. In fact, a star's habitable zone depends on a number of factors: the size of the star, the energy released, the atmosphere of the planets. Plate tectonics are also a feature of the Earth that other planets in the solar system do not possess, making it a flexible and adaptable world. In fact, researchers believe that if Mars had a tectonic plate system, it could be habitable. Mars, the red planet, here we come. Mars is the 4th planet from the Sun, the last planet before the asteroid belt, and the furthest from the Sun among the telluric planets of our solar system. Mars is 10 times less massive than the Earth. Like Mercury, it has similarities to the Moon, with craters and impact basins, volcanoes, rifts, valleys, dunes, and polar caps. Mars is home to the highest volcano in the solar system, Olympus Mons. Mars is also home to the world's largest canyon, Valles Marineris. Today, Mars is much less active than in the past. Volcanic eruptions are very rare. None have been observed by man. In 2013, a team of scientists from the University of Arizona published a study in the journal Nature Geoscience suggesting that a volcanic eruption occurred on Mars around 500,000 years ago. The team analyzed data from NASA's Mars Reconnaissance Orbiter and discovered deposits of volcanic ash and gas in a region called Cerberus Fossae. These deposits were similar to those observed on Earth during recent volcanic eruptions. Thus, significant volcanic activity could have taken place 1 million years ago. There are still a few minor geological events: landslides, earthquakes, geysers in the polar regions. Since the 19th century, scientists have been looking for traces of life on Mars. The first mission to explore Mars by flyby dates back to 1965 with NASA's Mariner 4 probe. Since then, knowledge of Mars has progressed enormously. It is now known that the red planet is not home to any multicellular life forms, but that there could be single-cell life somewhere in the bowels of Mars. Scientists therefore continue to search for traces of microorganisms on the red planet. But not only that, the latest studies of Mars also seek to better understand its geological development. On May 4, 2022, NASA's InSight probe recorded the strongest earthquake ever recorded on Mars, or any planet other than Earth. A magnitude 4.7 earthquake was recorded over a 6-hour period. An unexpected finding, given that Mars has no tectonic plate movements. This violent tremor could have been caused by a meteorite. However, the scientists found no evidence of a collision on the planet's surface to suggest this. Such an impact would have caused a crater 300 meters or 1,000 feet in diameter, with dust spewing out into space. But none of this was found. It would seem then that this magnitude 4.7 earthquake originated from Mars' internal activity. Solving this mystery will tell us more about the magma currents at work on Mars, its geological formation, and the causes of the loss of its magnetic field over billions of years. Mars still has plenty of surprises in store for us. A few months later, in October 2022, NASA discovered a gigantic meteorite impact crater on Mars. Its dimensions are impressive: 150 meters, or 500 feet in diameter, and 21 meters, or 70 feet deep. It's the largest meteorite impact crater ever discovered on a planet. To cause this impact, a meteorite of around 12 meters, or 40 feet, with a mass of between 250 and 650 tons, would have rushed into Mars at a speed of 7.5 kilometers per second, or 5 miles per second. This is consistent with an impact dating back to December 24, 2021, which had caused a magnitude 4 earthquake. The tremors caused by the impact brought out chunks of ice from beneath the Martian surface. Could this be a clue to the presence of underground liquid water on the red planet? We now know that Mars is an icy planet. It is covered by permanently frozen ground. All that remains now is to discover what this icy water contains which will be the focus of future Mars missions. On February 8, 2023, NASA announced that it had discovered the best evidence yet of the existence of lakes on Mars. An announcement that astonished many. Mars is an arid, dry environment with such low atmospheric pressure that even if temperatures allowed liquid water, it wouldn't persist. But in reality, the red planet wasn't always so barren. In fact, shortly after its formation some 4.5 billion years ago, Mars was very similar to Earth. Its atmosphere was denser and its temperatures warmer. Hundreds of millions of years ago, liquid water even carved out canyons on Mars. In February 2023, NASA discovered traces of waves on the planet's surface. The Curiosity rover found rocks whose surface is marked by undulations. These rocks have been miraculously preserved, giving us a glimpse into the red planet's past. All that remains now is to analyze these undulating rocks, which the rover has not yet been able to do due to their hardness. Six months after this discovery, another major breakthrough shook the scientific community. On August 9, 2023, a study was published in the journal Nature. This study revealed potential traces of life on Mars. In fact, they are fossil evidence of a cyclic climate. In other words, evidence that Mars was once organized into dry and wet seasons just like Earth. A regular cyclical climate is an environment conducive to the organization of simple organic molecules into complex organic compounds. In a word, conducive to life. Mars still holds many mysteries. Let's continue our exploration of the solar system, heading to the fifth planet from the Sun, Jupiter. On our way, we come across the asteroid belt. It was formed around 4.6 billion years ago, at the same time as the solar system. It's made up of several 100,000 asteroids that didn't aggregate to form planets. Or rather, small bodies of the solar system, i.e. celestial objects that are neither planets nor satellites. The hundreds of thousands of small bodies that make up the asteroid belt vary enormously in size. They range in size from a speck of dust to several hundred kilometers in diameter. Among these small bodies, there is just one dwarf planet, Ceres. With a diameter of 950 kilometers or 590 miles, Ceres alone represents almost a third of the mass of the asteroid belt. And yet, it's a small dwarf planet, 14 times less massive than Pluto. It's also the only spherical object in the asteroid belt. The other objects are all irregularly shaped. Ceres has a rocky core, a mantle of water ice representing 25% of the planet, and a rocky crust with salt deposits. A structure similar to that of the telluric planets of the solar system. Discovered as early as 1801, it is now of interest to scientists for several reasons. First, it is thought to be a protoplanet. If so, it could provide clues to the formation and evolution of planets in the solar system. Secondly, Ceres may have once sheltered an ocean of liquid water. What's more, data collected during the flyby of this dwarf planet by the Dawn probe, launched by NASA in 2007, had aroused the curiosity of scientists. The Dawn probe was placed in orbit around Ceres in 2015. In 2017, it detected the presence of complex organic molecules. The origin of these compounds from the hydrocarbon family had not been fully elucidated. Scientists had put forward several hypotheses, concluding that they could have been brought by comets or formed from compounds present in salt water. A study in October 2023 has reignited the debate. New analyses have shown that the origin of these compounds could be endogenous. In other words, they could have formed on Ceres thanks to the presence of water. So, at the heart of this dwarf planet in the asteroid belt, there could be a reservoir of organic compounds. Another asteroid in the asteroid belt between Mars and Jupiter has been in the news recently, 16 Psyche. 16 Psyche is one of the most massive asteroids in the asteroid belt. It is 226 kilometers, or 140 miles wide, and very heavy. Composed of between 30% and 60% metal, it represents just under 1% of the mass of the entire asteroid belt. According to NASA, this asteroid has a core of iron, nickel, and gold. This could be the residual core of a primitive planetesimal. In other words, the metallic core of a dead planet. This asteroid could then help us better understand the composition of the Earth's core. The Psyche mission was launched in October 2023 to find out more. It will take 6 years for the space probe to reach 16 Psyche. Exploration of this promising asteroid will therefore not begin until August 2029. At that point, the space probe's mission will be to map the asteroid and study its properties. Let's resume our journey through the solar system. We're now about 779 million kilometers, or 485 million miles from the Sun, beyond the asteroid belt. You're looking at the largest planet in the solar system, Jupiter. Jupiter is a gas giant. It is larger than all the other planets in the solar system combined, with a radius 11 times that of the Earth and a mass 318 times greater. It's so massive that it's visible to the naked eye from Earth, and has been known about since prehistoric times. It is, after the Sun, Moon, and Venus, the fourth brightest object in our night sky. Jupiter's composition is similar to that of the Sun, mainly hydrogen and helium. Jupiter's atmosphere is very thick. Because it's a gaseous planet, it's difficult to know where the boundary lies between its surface and atmosphere. Jupiter may contain a small rocky core like Earth's, but scientists have yet to prove this. Jupiter has the shortest day of any planet in the solar system. It completes a full revolution on itself in less than 10 hours. Because of this ultra-fast rotation, Jupiter is flattened at the poles and domed at the equator. On the other hand, Jupiter's years are long. 1 year on Jupiter is equivalent to just under 12 Earth years. Jupiter, its 95 moons and rings, are known as the Jovian system. Jupiter's moons are satellites attracted by its gravitational force. Scientists have given names to some 50 of these moons. Jupiter's influence extends even beyond the Jovian system. A group of asteroids known as Jupiter's Trojan asteroids share its orbit around the Sun. In 2023, several discoveries were made on Jupiter. In February 2023, astronomers searching for a ninth planet at the edge of the solar system came across 12 new Jovian moons. These moons are not as impressive as Ganymede, Jupiter's largest moon. The moons are quite small, ranging in diameter from 1.5 kilometers or 1 mile to 5 kilometers or 3 miles. They were discovered almost by accident. Discovering new moons around Jupiter is complicated, not only because Jupiter is so bright that its brilliance obscures that of small moons, but also because it takes powerful telescopes with a wide enough field of view to capture the immense Jovian system. But Jupiter found itself in the telescope sights of scientists whose mission it was to find the ninth planet. Thanks to the high-performance tools used by the scientists, only 4 images were needed to cover the entire Jovian system. The first signs of these new moons were detected in March 2017, but it took some time to confirm their existence. Of these 12 moons, 9 are retrograde, meaning they revolve around the Sun in the opposite direction to the Earth and most other planets and asteroids. These moons are therefore thought to be small lunar debris, the result of collisions that destroyed much larger moons, and to have been captured by Jupiter. In other words, these bodies were not born in the Jovian system, but were drawn there by Jupiter's impressive gravitational force. Jupiter's moons are a prime target for researchers, who are taking a close interest in them in the hope of finding traces of life. On April 14, 2023, the JUICE probe lifted off for Jupiter. The probe is named JUICE for Jupiter Icy Moon Explorer. In other words, its main objective is to explore Jupiter's icy moons. It will enter the Jovian system in 2031, flying over the moons Callisto, Ganymede, and Europa. It will then orbit Ganymede, Jupiter's largest satellite, for ideally 1 year. By September 2023, discoveries had been made on Europa, the smallest of the 4 Galilean moons. The James Webb Telescope found traces of carbon dioxide on the moon's surface. This discovery supports the hypothesis that Europa contains an underground ocean of water. This ocean would probably be salty, with a depth of around 100 kilometers or 60 miles. If the CO2 detected on Europa's surface does indeed come from this ocean, then Europa could join Saturn's moon Enceladus at the top of the list of most habitable places in the solar system. James Webb made another important discovery in October 2023. His images revealed a previously unseen feature of Jupiter's atmosphere. In this photo, you can see an incredible high-speed jet stream stretching over 4,800 kilometers or 3,000 miles above the main cloud decks north of Jupiter's equator. Until now, this feature has always been seen as hazy mists in Jupiter's atmosphere. But the incredible precision of the James Webb Telescope has given us a clearer picture. This discovery is one step closer to understanding the interactions between the layers of Jupiter's atmosphere. Let's continue our journey through the solar system. We're now approaching Jupiter's neighbor, Saturn. Saturn is the second largest planet in the solar system. It is best known for its magnificent rings, which average 10 meters or 30 feet in thickness, but in some places stretch to 100 meters or 330 feet. Scientists believe that Saturn didn't always have these rings of ice and dust. They may have been created when one of Saturn's first moons collided with the young planet. Around 100 million years ago, a moon orbited Saturn. This moon eventually came very close to the planet, orbiting it faster and faster. The acceleration eventually caused the moon to explode, its fragments scattering around Saturn to form a disk. In the distant future, it is highly likely that Saturn will gradually lose its rings, disappearing completely in around 300 million years. A Saturnian day lasts 10.5 hours, but a Saturnian year lasts 29.5 Earth years. Saturn is the planet with the most moons in the solar system. After the discovery of 12 new moons around Jupiter in February 2023, Jupiter was the planet with the most moons. Saturn had 83. But in May 2023, 62 new Saturnian moons were discovered, bringing the planet's total number of satellites to 145. How were these moons discovered? Moons are difficult to detect, not only because they move, but also because they are often so small that they don't reflect enough light. To discover these 62 moons, scientists took multiple images of a large window of sky every 5 minutes for 3 hours over a 3-year period with the Canada-France-Hawaii telescope. These images were then combined to form a single image. And then, surprise, 62 new moons of Saturn were revealed. These 62 moons are known as irregular. Like the 12 moons discovered around Jupiter in early 2023, they were formed before being captured by Saturn's gravitational influence. They are the result of various collisions, the oldest of which date back billions of years. Further discoveries were made at the end of 2023, revealing more of Saturn's hidden mysteries. On October 22, 2023, a mysterious phenomenon was photographed by Hubble: spots on the planet's rings. These mobile, seasonal spots are known as ring rays. They had already been observed by the Voyager 1 probe in 1981, then by the Cassini probe. For the moment, researchers are unable to explain their origin. Perhaps they result from the interaction between the solar wind and Saturn's magnetic field. This would generate powerful electrostatic forces, lifting dust and ice above the rings. What we do know is that the number of spots and their contrast vary according to Saturn's seasons, which last 7 years each. Right now, as we approach Saturn's equinox, the ring rays should increase in frequency and become darker. But there is currently no theory to predict when these rays will appear. Another mystery: while the spots usually appear on only one side of the ring, Hubble was able to observe them on both sides. And they're not as small as they look. They can extend far beyond the Earth's diameter. Shortly after the release of this Hubble photo, another discovery, this time by ESA, caused quite a stir. According to ESA, a cosmic phenomenon is set to occult Saturn's rings for 7 years, an extremely rare event. This cosmic phenomenon is linked to Saturn's orbital motion. On August 27, 2024, Saturn will reach its brightest point and most prominent size. Saturn's gradual inclination will end in March 2025. After this date, Saturn's rings will no longer be visible. Very recently, on February 7, 2024, a striking new discovery was published in the journal Nature. This time, the discovery concerns a moon of Saturn that we don't hear much about. It's called Mimas. Mimas is the smallest of Saturn's 7 main moons. It has joined the very exclusive club of habitable moons alongside the Saturnian moons Titan and Enceladus, and the Jovian moons Europa and Ganymede. And why? Because it too is said to harbor an ocean beneath its surface. An unexpected discovery, to say the least. Mimas is said to harbor an ocean 72 kilometers or 45 miles deep, beneath a frozen crust 24 kilometers or 15 miles thick. This sea would have appeared less than 25 million years ago and would account for more than half of Mimas's total volume. As early as 2014, the possibility that Mimas was home to an ocean had been raised. The moon oscillated unexpectedly around Saturn. In fact, Mimas's orbit has drifted by around 10 kilometers or 6 miles in 13 years. This has now been confirmed. However, Mimas's ocean would be relatively young from an astronomical point of view. In other words, it's likely that life hasn't had time to appear there. Something to keep an eye on. Let's continue our journey through the solar system to the 7th planet from the Sun, Uranus. Uranus is the 3rd largest planet in the solar system after Jupiter and Saturn. It is 4 times larger than the Earth. It is also the coldest planet, along with its neighbor Neptune. Both are what we call icy giants. Its atmosphere is composed mainly of hydrogen, helium, methane, and ammonia. Its magnificent blue-green color is due to methane. One of Uranus's particularities is that its axis of rotation is tilted by 98 degrees Celsius or 210 degrees Fahrenheit. This gives the planet the impression of rolling in its orbit, and it represents the same pole to the Sun for 42 years. Like Saturn and Jupiter, Uranus has 13 rings made of rock and dust. But these are very dark. Uranus also has 27 known moons. The 5 largest known moons of Uranus are Titania, Oberon, Umbriel, Ariel, and Miranda. These 5 moons have particularly attracted the attention of researchers in recent years. Why shouldn't they, like the moons of Saturn and Jupiter, harbor underground oceans? The Voyager 2 probe flew past Saturn, Uranus, and Neptune in the 1980s. In fact, it was the only probe to come so close to the 2 icy planets. The data it collected is still being studied by scientists. And because water has been found in such unlikely celestial bodies as Ceres, Pluto, and Mimas, hopes have naturally turned to the moons of Uranus. The findings of recent studies have rekindled these hopes. With the exception of Miranda, these moons could indeed harbor an underground ocean, especially the 2 largest, Titania and Oberon, which could harbor an ocean that is thicker and warmer than the other 2 moons, and therefore potentially inhabited. Unless, of course, all these moons harbor only residual oceans or relics of former oceans. So, inhabited oceans or residual oceans? Future missions to the moons of the largest icy giant planet could tell us more. Take a look at this photo of Uranus. It was taken on February 6, 2023 by the James Webb Telescope. In this photo, you can see the icy giant surrounded by several moons and 11 of its 13 dust rings. Some of these rings had not been photographed since 1986. Future images should reveal 2 more outer rings discovered by Hubble in 2007. With this photo, James Webb delivers essential information that will help us better understand Uranus's seasons. We can also see Uranus's famous and mysterious polar cap. Because Uranus is inclined at 98 degrees to the plane of its orbit, its seasons are extreme. At the poles, days and nights last for years. The polar cap disappears in summer, when it's in full sunlight, and mysteriously reappears in autumn, when the pole is plunged back into darkness. The photo also shows 2 bright clouds that could be storms. In December 2023, the telescope revealed another image of Uranus to clarify these observations. This new image enabled us to observe certain features of Uranus in greater detail: the white inner cap and the dark band at the bottom of the polar cap towards lower latitudes. Several storms are also visible near the southern edge of the polar cap. Astronomers are eager to observe the changes that are sure to occur in 2028, when Uranus reaches its next solstice. On May 23, 2023, further images of Uranus were published. This time, these were not James Webb photos, but a combination of shots taken in 2015, 2021, and 2022. Astronomers have taken advantage of a particularly propitious period to observe Uranus. It's only since 2015 that we've been able to observe Uranus's poles properly, for the first time in almost a century. That's right, it takes the icy giant 84 years to circle the solar system. Using the Very Large Array Telescope, astronomers have studied Uranus's polar atmosphere under the radio wave spectrum and detected a polar cyclone, a first. And above all, another indication that Uranus is far more dynamic than previously thought. The discovery also confirmed that all the planets in the solar system share a common feature: vortices or whirlpools at their poles, except Mercury, whose atmosphere is too tenuous. NASA has made Uranus one of its priorities since 2023. An observation program has been launched until 2032. It is called Uranus Orbiter and Probe. We are now 4.5 billion kilometers or 3 billion miles from the Sun. The second ice giant, Neptune, is the furthest planet from the Sun. At times, it's even further away than the dwarf planet Pluto. It's so far away that the only spacecraft to visit Neptune, Voyager 2, took around 12 years to get there. It's the 4th largest and 3rd most massive planet in the solar system. It is 17 times more massive than Earth. It is also the densest giant planet. Neptune is not visible to the naked eye. It was therefore discovered by deduction rather than direct observation, unlike the other planets in the solar system. Based on astronomers' calculations, it was first observed in 1846. Neptune takes around 165 Earth years to orbit the Sun. A day on Neptune lasts about 16 hours, and each season lasts 40 years. Neptune has a solid core of silicates, nickel and iron, equivalent to 1.2 times the size of the Earth. This core is surrounded by a hot fluid composed of icy materials such as water, methane, and ammonia. Neptune has no solid surface. Its atmosphere is composed mainly of hydrogen and helium, with traces of methane. It is the windiest planet in the solar system, with winds reaching up to 2,100 kilometers per hour or 1,300 miles per hour. Neptune's Great Black Spot has long intrigued scientists. This enormous storm in the planet's southern hemisphere was spotted during Voyager 2's flyby in 1989. Its winds reached speeds never before recorded on any planet in the solar system. It had completely disappeared by 1994. Another similar spot appeared in 2016, this time in Neptune's northern hemisphere. In September 2022, the James Webb Telescope photographed Neptune with its rings. This unprecedented photo shows not only Neptune's thin rings, but also some of the planet's moons. In this image, Neptune sparkles with a blinding brilliance, like a faceted ball. It shines brightest at higher latitudes and at the poles. Scientists believe that these particularly bright areas are active regions, reflecting more sunlight than the planet's other methane-rich regions. In the image, Neptune is streaked with fine white lines, which NASA believes are signs of atmospheric circulation. In fact, these lines represent matter moving down from the high latitudes towards the equator as it heats up. A wider view, also broadcast by James Webb, shows Triton, Neptune's largest moon, shining even brighter than Neptune itself. In the image, Triton looks like a star. In fact, Triton shines so brightly because it is covered in nitrogen ice, which causes it to reflect around 70% of the sun's light. A total of 7 moons can be seen out of Neptune's 14 known satellites. Triton, then inside Neptune's rings, Galatea, Naiad, Thalassa, Despina, and finally Larissa. The colors are not bright, as the image was taken in the infrared. We tend to say that Neptune is dark blue and Uranus light blue. Is this true? According to recent images and the analysis of researchers, no. In fact, the two icy giants are both dark blue. In fact, both icy giants are the same color, a light shade of greenish blue. In fact, at the time of Voyager 2 and the first images of Neptune, scientists had forced the contrast to better distinguish clouds and winds on the images. In other words, Neptune had been artificially made much bluer than it really was. We knew this at the time, but the accuracy was lost over time, until it was thought that the bright blue was Neptune's true color. In January 2024, researchers at Oxford University re-established the truth by publishing photos of the two planets in their true colors. Another mystery hovers around the two icy giants: diamond showers. As early as the early 80s, it was thought that diamond hearts might exist within Uranus or Neptune. These diamond cores would form under the action of the enormous pressures acting on the carbon compounds detected in their atmosphere. More recently, studies have been carried out on the formation and appearance of diamond showers in icy giants. That is, Neptune and Uranus, but also those outside the solar system. The results were astonishing. Diamonds could appear at lower temperatures and pressures than previously thought. There could well be diamond showers on Neptune and Uranus, in the shallow layers of their atmospheres. We have completed our exploration of the planets of the solar system, but we haven't reached the end of our adventure yet. We still have a few objects to explore and a few mysteries to unravel. Let's take a closer look at Pluto. Pluto was long considered the 9th planet in the solar system until 2006, when it was classified not as a planet, but as a dwarf planet. Let's take a step back in time. Years before Pluto's existence was discovered, it had already been suspected. Researchers had identified anomalies in the motions of Uranus and Neptune. In fact, the two planets were moving through space as if another object were disrupting their trajectory. Astronomers searched the skies for years, looking for what they called Planet X. What they didn't know was that it was a planet. What they didn't know was that these disturbances were not due to the presence of a third planet interacting gravitationally with them. Rather, they were due to an incorrect estimate of Neptune's mass. In any case, a 9th planet was discovered in 1930. It was soon realized that it was too small to have influenced the motion of Uranus. Little by little, researchers refined their knowledge of this 9th planet called Pluto. It soon became clear that Pluto differed in size from the other 8 planets in the solar system. Pluto is very small indeed. Its diameter is just 2,376 kilometers, or 1,500 miles, half that of Mercury, itself very small compared to the other planets in the solar system. What's more, Pluto's orbit is very inclined and flattened. It moves through space more like a comet than a planet. But Pluto isn't a comet, it's spherical in shape, and like its neighboring planets has satellites. So we had to ask ourselves the following question. Does Pluto meet the criteria that make a planet a planet? These criteria are as follows. The planet orbits the Sun. The planet has sufficient gravitational force to have a spherical shape. The planet has sufficient mass to clear its orbit of debris. Pluto meets only the first two criteria. It has therefore been downgraded to a dwarf planet. Since 2006, there have been 8 planets in the solar system. These are the 8 planets we explored on this trip: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. The solar system also includes 5 dwarf planets: Ceres, Pluto, Haumea, Makemake, and Eris. Pluto never ceases to intrigue researchers, not least because of its chaotic orbit. That's right, Pluto's orbit is very inclined compared with other planets in the solar system, and seems to be subject to disturbances over short periods. Pluto takes 248 Earth years to orbit the Sun. It is separated from the Sun by 6 billion kilometers, or 4 billion miles. On average, because there is a difference of 20 astronomical units between its aphelion and perihelion, this means that every orbital period, Pluto orbits closer to the Sun than Neptune for around 20 years. Despite extensive research, scientists have been able to pinpoint the cause of Pluto's chaotic orbit. One of the most commonly accepted theories is that of planetary migration. In other words, Pluto was pulled into its resonance by Neptune as it migrated to the outer regions of the solar system early in its history. However, this theory does not explain Pluto's inclined orbit. In October 2023, another surprising discovery was made on Pluto, that of a cryovolcano. In other words, an ice-spitting volcano. This volcano, said to be the size of a country like Cyprus, is said to have erupted several times. In the process, it would have spewed out some 1,000 square kilometers, or 385 square miles of ice, enough to bury a megalopolis like Los Angeles. This discovery was made thanks to data from the New Horizons probe, launched by NASA in 2015 to study the structure of Pluto and its satellites. This probe had come within 11,000 kilometers, or 6,900 miles of Pluto, in July 2015. This led to the discovery of the Kilad's crater, which extends over 44 kilometers, or 27 miles. It could be the result of collapses caused by eruptions and is thought to be a few million years old. Proof not only of Pluto's intense seismic activity, but also of its geological variety. On Pluto, cryovolcanoes have been found, as well as icy plains, ridges several kilometers high, and even a heart-shaped glacial region 2,000 kilometers, or 1,300 miles wide. Beyond Neptune's orbit lies the Kuiper Belt. This is actually a ring-shaped region populated by almost 100,000 icy bodies over 100 kilometers, or 60 miles in size, and several billion comets. The Kuiper Belt is larger than the asteroid belt. It is 20 times wider and between 20 and 200 times more massive. Like the asteroid belt, it is made up of small bodies left over from the formation of the solar system. But unlike the asteroid belt, which has just one dwarf planet, the Kuiper Belt has at least three: Pluto, Makemake, and Haumea. The dwarf planet Eris is not considered part of the Kuiper Belt. Kuiper Belt objects are mostly made up of frozen volatile compounds such as methane, ammonia, or water. The first Kuiper Belt object to be discovered was named QB1. It was discovered in 1992. The study of the Kuiper Belt is important, not only because it surely contains clues to the early solar system, but also because it is thought to be the source of short-period comets. It would therefore be a kind of reservoir for this type of comet, in the same way as the Oort cloud is a reservoir for long-period comets. For these reasons, the Kuiper Belt was explored by the New Horizons probe, which flew past it in 2019. At the end of May 2023, data from its observations were presented at a scientific conference. Surprising data suggesting that there could be a second Kuiper Belt. However, the researchers behind this discovery caution against jumping to conclusions. For the moment, it's just a hypothesis. Another discovery concerning the Kuiper Belt was made in September 2023, this time by Japanese astrophysicists. It would appear that the Kuiper Belt is home to a planet larger than the dwarf planets listed there. This hypothetical planet has not been observed directly, but deduced from the strange, steeply inclined orbits of certain Kuiper Belt objects. This suggests that these objects are under the gravitational attraction of another larger body. The presence of a planet is one hypothesis among others, but it is consistent with the simulations. If it exists, this planet would have a mass 1.5 to 3 times that of the Earth. Its inclination would be around 30 degrees, and its orbit would take it to a distance of between 250 and 500 astronomical units from the Sun. All that remains is to confirm the presence of this planet. This planet would be different from the 9th planet, whose existence scientists are trying to prove. There could in fact be a 9th planet beyond Neptune's orbit. This would explain the orbits of certain objects in the Kuiper belt. But this hypothesis still divides scientists. We'll have to wait for more concrete proof before it is unanimously accepted. What lies beyond the Kuiper belt? Because the Kuiper belt doesn't mark the end of the solar system, the Oort cloud is still hypothetical, as it has never yet been observed. This cloud would occupy a vast zone of space between the outer edge of the Kuiper belt at around 50 AU and extend out to 1 light year, the distance it would take light to travel 1 year. The cloud would be subdivided into the spherical outer Oort cloud and the torus-shaped inner Oort cloud. The question of the limits of the solar system is a subject of fascinating debate in the astronomical community, revealing that the boundary of our planetary system is not a fixed notion, but rather a fluctuating concept, depending on the criteria chosen to define it. The first perspective, popularized by the historic voyages of the Voyager probes, focuses on the heliopause as a marker of the solar system boundary. The heliopause represents the boundary where the solar wind, a stream of energetic particles emitted by the Sun, is stopped by the interstellar medium. In 2013, Voyager 1 crossed this boundary some 19 billion kilometers, or 12 billion miles from Earth, marking humanity's first foray into interstellar space. However, this definition is based primarily on the Sun's electromagnetic influence, not its gravity. Another definition, supported by many astronomers, takes into account the Sun's zone of gravitational influence. In this perspective, the limits of the solar system extend to the outer edge of the Oort cloud. To better grasp the immensity of our solar system, let's imagine it on a reduced scale, with the Sun represented by a yellow ball 1 centimeter in diameter instead of its actual 1.4 million kilometers, or 870,000 miles. In this miniature perspective, the Earth, which is 109 times smaller than the Sun, would be transformed into an almost imperceptible 0.1 millimeter grain of sand, located 1 meter away from our miniature star. This distance would correspond to 150 million kilometers, or 93 million miles in space, or 1 astronomical unit, AU. On this scale, Jupiter would be 5 meters or 16 feet from the Sun, Neptune 30 meters or 98 feet, and Pluto would float at around 40 meters or 130 feet, with a Kuiper belt stretching between 30 and 55 meters, or between 98 and 180 feet from our miniature star. However, even on this scale, we would not yet have reached the outer reaches of the solar system. The Oort cloud would mark the outer limit, extending to around 100 kilometers or 62 miles from our miniature Sun. So, if the Sun were compared to a small yellow marble, its gravitational influence would extend over a sphere with a radius of 100 kilometers or 62 miles. To put things into perspective, Proxima Centauri, the nearest star to our solar system, would be 400 kilometers or 250 miles away in this reduced model. Our journey is coming to an end. Through this exploration, you will have understood that our solar system is very complex, and yet it's far from unique. In the vastness of our universe, the solar system is just one of many planetary systems. Each of these planetary systems consists of a star with planets in orbit. To date, over 3,200 stars with planets orbiting them have been discovered, and that's just the beginning. So yes, the solar system is far from unique, but one wonders how rare its configuration is on the scale of the universe. And indeed, of all the planetary systems in our universe that have been studied, it appears that there is a wide variety of possible structures. So far, we haven't found anywhere else a structure like that of our solar system, with only dense, rocky planets closer to the star on one side and only gas giant planets further away on the other. Could our solar system be an exception? Perhaps, because scientists believe that the arrangement of planets in our solar system is indeed due to chance. A happy coincidence for us.